You are listening to The Vocal Technologist. Spoken Tech for your ears.
Imagine the ultimate cyber threat, right? You probably picture, I don't know, a bank heist movie. Like a shadowy human figure hunched over a glowing keyboard in a dark room, furiously typing to pick the digital locks of some classified mainframe.
Right, the classic Hollywood hacker.
Exactly.
Okay.
But you need to throw that entire image out the window because today, your biggest cyber threat is a multi-million-dollar artificial intelligence generating the exact same password for thousands of different people. And a hacker remotely hijacking a $5,000 robot lawnmower to run over a reporter just to prove they can.
Yeah, welcome to early May 2026. It's a profound structural shift
It really is.
because the definition of a threat has fundamentally moved away from human ingenuity,
Yeah.
right, toward these autonomous software agents. And the irony we are seeing this week is that as the attacks get exponentially more sophisticated, our oldest, most basic digital defenses are suddenly our biggest liabilities.
Which is exactly our mission for you today. Whether you're prepping for a massive IT strategy meeting or you're just, insanely curious about the fragile digital systems running your life, this deep dive is going to give you a masterclass in the current state of digital trust.
And we've got a lot to cover.
We've got a massive stack of information security newsletters here, and we are going to strip away all the jargon to uncover how the cyber war is actually being fought right now.
The sheer volume of incidents this week is just staggering. I mean, we really need to move past the idea of using an AI to draft a convincing phishing email.
Right, that's basically ancient history at this point.
Exactly. We are now looking at AI actively participating in network warfare as the attacker, the primary defender, and in a lot of cases, the infrastructure itself.
Okay, let's unpack this because we really need to start at the bleeding edge. So, the UK's AI Security Institute, the AISI, they just finished evaluating OpenAI's GPT 5.5.
Yeah, and the results are legitimately wild.
They really are. The model trivially completed standard capture the flag hacking challenges. But more than that, in 2 out of 10 attempts, it actually beat their end-to-end enterprise network challenge.
Which is huge because that mimics a fully defended real-world corporate environment.
Right. But what stood out to you from that data?
Well, the most revealing data point from that AISI evaluation, to me anyway, was where the model actually failed. It completely failed on the industrial control systems challenges.
Okay, so it masters the digital logic and the network architecture, but it still stumbles when it has to interact with, the physics of real-world infrastructure, like power grids or water plants.
For now, yes. It struggles with the physical layer. But look at what is happening on the purely digital side. At the B-Side San Francisco conference this year, 16 different teams fully solved every single capture the flag hacking challenge.
Wow, and let's put that in context for you. Last year, in 2025, how many teams managed to solve them all?
Just one team.
One team. That is a terrifying leap in 12 months. I mean, did humans just get 16 times better at hacking?
No, the humans didn't change at all. The tools did.
Ah, okay.
Autonomous agents, like Claude Code and Codex, they are now cracking medium difficulty binary exploitation challenges in minutes. It's no longer a test of human hacking skill or creative problem solving.
So what is it a test of now?
The competition has fundamentally shifted to resource allocation. It's all about who has the massive infrastructure budget to spawn the most parallel AI agents the fastest.
That is wild. It's like we spent decades building thicker vault doors, and the attackers responded by training 1 million tiny invisible locksmiths to test every single permutation of the lock simultaneously.
That's a great way to put it.
And the scale of the attack is breaking the systems designed to track them. Like, I'm looking at this announcement from the National Vulnerability Database, the NVD.
Yeah.
They are dropping CVE enrichment for a huge chunk of new vulnerabilities.
Yeah, this is a massive problem.
Let's pause there for a second. For anyone who isn't deep in vulnerability management, what exactly is enrichment and why is dropping it such a big deal?
Right, so when a new vulnerability, a CVE, is discovered, it's basically just a raw, unstructured report. Enrichment is the vital process of adding metadata to that report.
Like giving it a score.
Exactly. Human analysts assign a severity score, they identify exactly which software versions are affected, and they categorize the specific type of weakness. It's the context that tells a corporate security team, hey, drop everything and patch this immediately, versus, you can ignore this, it doesn't apply to your systems.
So it's a triage process.
It is the entire triage process,
Yeah.
and the NVD had to stop doing it for many bugs because AI tools like Anthropic's Claude Mythos have enabled automated agents to find and submit so many vulnerabilities that the human analysts literally cannot process the volume anymore.
So security teams who rely on those scores for prioritization are suddenly just flying blind.
Completely blind.
And it's gotten so severe that the White House is weighing pre-release reviews for high-risk models specifically because of that Anthropic Mythos preview. NHS England just ordered hundreds of their GitHub repositories to be closed off from public view over AI security concerns.
Right, the big institutions are definitely panicking.
Yeah, while the governments and massive institutions are panicking, everyday developers are just, vibing.
Oh yeah, the vibe coding trend.
I gotta say, I have to push back on this whole concept. How did we go from rigorous software engineering where every single line of code is tested to just vibing our way into application development?
It's a huge shift in the culture.
Definitely. Red Access actually published a report on these vibe coding apps, tools like Replit and Lovable. The premise is you just describe what you want in plain English, and the AI builds the entire application.
Sounds great in theory, right?
Yeah, until you see the results. The report found 5,000 publicly accessible websites leaking highly private data. We're talking hospital records, financial info, private conversations, just sitting out in the open.
Because the person vibing the app didn't explicitly ask the AI to include user authentication.
Exactly. They just forgot to say, make a login screen.
What's fascinating here is that we are witnessing a profound shift in how technology is built. We've moved from LLMs acting as an informational GPS, where they suggest routes, but a human developer is still driving the car, to a self-driving Waymo model.
Yeah, the AI is totally at the wheel.
Right. The AI writes the code, provisions the database, and deploys the server. But an AI doesn't understand context or risk. If you don't explicitly prompt it to build a login screen, it just assumes the data is meant to be public.
And these models leave fingerprints everywhere. This part blew my mind. GitGuardian researchers proved that they can identify AI-generated passwords with incredibly high accuracy. They found 28,000 of them just sitting exposed on GitHub.
Well, that's because LLMs are fundamentally statistical prediction engines. They are not capable of true randomness. And the researchers used Markov chains to prove this.
Okay, break down how a Markov chain works in this context, because that sounds super technical.
Sure. A Markov chain is essentially a mathematical system that maps the probability of moving from one state to another. In language models, it maps how likely one character or word is to follow the previous one based on its training data.
Oh, I see.
So when an AI tries to generate a random sequence, its underlying statistical weights pull it toward predictable, recurring patterns.
So if I ask an AI to generate a highly secure random password, it's probably going to spit out the exact same password it gives thousands of other users because the math inevitably leads it down the same path.
The data proves it. The researchers show that Claude Opus 4.6 generates completely unique passwords only about 35% of the time.
Wow, that is terrible.
And Llama models have recurring substrings that show up in 96% of their password outputs. If attackers know you used an AI to generate a secret key, they can use those same statistical probability models to crack it exponentially faster than traditional brute force guessing.
But this leads to an even bigger structural issue, right? Regarding how we handle security flaws. If an AI agent discovers a vulnerability in an open source project and that interaction is logged anywhere, that specific vulnerability might end up in the next generation's training data.
Exactly. Which completely destroys the concept of a coordinated disclosure embargo.
How so?
Well, traditionally, when a researcher finds a bug, they privately tell the software vendor and agree to keep it secret for 90 days so the vendor can fix it. But you can't swear a machine learning model to secrecy.
Right, it doesn't understand NDAs.
No, it doesn't. If that vulnerability enters the training data, it becomes discoverable by anyone clever enough to query the model the right way.
Okay, let's shift gears a bit, because if these AI agents are now writing the code, breaking the code, and leaking the data, how are the human attackers adapting to this?
You're going straight to the source.
Right, they aren't trying to break down the front door of the network anymore. They are poisoning the very tools developers use to build the house. Like, I was looking at this discovery by OX Security regarding Anthropic's MCP STDIO implementation.
Oh, that was a huge finding this week.
Yeah, it's a remote code execution vulnerability at the absolute core of the framework. But the report explicitly says it's not a bug. They call it RCE by design.
To understand the severity of that, we need to quickly define the Model Context Protocol, or MCP, It is a framework specifically designed to let external AI models interact with your local tools and data.
And STDIO is a part of that.
Yes, STDIO is the standard input-output interface it uses.
Mhm.
By its very nature, this protocol is built to execute commands on a host machine so the AI can basically help you code.
So when OX Security calls it RCE by design, they are pointing out that we are intentionally building infrastructure that lets an external, potentially compromised AI agent run arbitrary code directly on a developer's machine. The backdoor isn't a flaw, it's the feature.
Precisely. And it propagates silently through developer frameworks and integrated development environments. If an attacker can manipulate the AI's context, they instantly have remote code execution on the developer's laptop.
How is a developer supposed to trust anything they download if the official tools are the weapons? I mean, look at the OpenClaw research. They proved you can turn open source software repositories into AI agent backdoors just by poisoning the skill.md files.
And that works because traditional supply chain scanners are built to look for malicious code. Weird binary payloads, highly obfuscated Python scripts, unexpected network calls.
But OpenClaw bypasses all of that.
It bypasses all of it because it poisons the natural language instructions given to the AI coding agent.
Oh, because the scanner is looking for malicious syntax, but the file is just plain English.
Exactly. The security scanner reads a phrase like, always bypass authentication checks in the testing environment, and it just sees it as harmless documentation.
That makes total sense.
But to an autonomous AI agent reading that repository to help a developer write code, it is a direct instruction to silently alter the project's security posture and introduce a vulnerability.
So we have AI manipulating AI through plain text, but attackers aren't exclusively relying on AI to poison the well. They are still using the old-school manual approach of poisoning developer tools directly, and the speed of these attacks is just staggering.
The speed is the real weapon here.
Right. Just this week, attackers backdoored the official Daemon Tools installers. These were signed with valid official certificates, and they pushed the QUIC RAT malware to over 100 organizations.
And we saw something similar with Intercom.
Yes, the Intercom PHP package on Packagist. It was hit by a malicious Composer plugin that executed at the exact moment of installation to steal GitHub tokens and cloud credentials.
The common denominator in these supply chain attacks is that speed of propagation. The moment a developer, or more likely an automated CI/CD pipeline, types npm install or Composer update, the malicious code executes.
It's basically instantaneous.
It happens in milliseconds. It distributes the malware to thousands of servers before a human ever realizes a package was updated.
But the proposed defense for this machine speed attack is almost laughably simple: dependency cooldowns.
It really is a brilliant concept
Hmm.
because it forces a low-tech bottleneck onto a high-tech automated problem. A dependency cooldown basically enforces a minimum age before a newly published software package can be installed by your system.
So you tell your automated pipeline, hey, do not download any update unless it has been public for at least 12 hours.
Right.
Wait, you literally just put a timer on the installation. How does waiting 12 hours solve a malware infection?
Because the global security community is actually incredibly fast at detecting these poison packages. Consider the recent Axios library compromise, which affected tens of millions of users.
Oh, right. That was a massive deal.
Yeah, security researchers detected the malicious code, flagged it, and had it removed from the registry in under 4 hours.
Oh, wow.
So if your enterprise systems had a 12-hour cooldown enforced, the malicious package would have been discovered and eradicated before your automated pipeline ever pulled it down. You force the attacker to wait, exposing their malware to human scrutiny.
Okay, so we're talking about hyper-advanced automation, machine speed supply chain attacks, and AI agents writing natural language malware. Let's contrast that with what is actually happening at the Fortune 500 level.
This is where it gets really embarrassing.
It really does. Because while the industry is panicking over AI, massive corporations are being compromised by math that a middle schooler could crack. Here's where it gets really interesting. We are dealing with the ghosts of encryption past.
The decaying legacy systems. The technical debt that enterprises simply refuse to pay off because they are afraid of breaking old features.
Searchlight Cyber published a report on Salesforce Marketing Cloud. They found a legacy XR encryption scheme that allowed them to read emails across every single Fortune 500 instance hosted on the platform.
Which is just wild to think about.
It is. Let's break down XOR encryption, because relying on it for enterprise email security is insane. XOR is basically applying a simple mathematical mask over your data. If you apply the exact same mask a second time, the data reverts to plain text.
Right, it is reversible logic.
Yeah.
And the specific scheme Salesforce was using relied on a static, repeating string and a laughably simple checksum, literally just adding up the bytes.
It's like trying to secure a bank vault with a serial box decoder ring. If the mask never changes, an attacker can trivially peel it off. How is it possible that massive platforms are relying on this level of cryptography?
Well, it comes down to how enterprise software scales. That XOR encryption scheme wasn't designed to withstand modern cryptographic attacks. It was likely implemented over a decade ago just to obfuscate URL parameters so casual users wouldn't mess with them.
Okay, that makes sense for back then.
Right. But as the platform grew, that legacy code became deeply embedded. Engineers rarely rip out old code because it might break an integration for a legacy client paying millions of dollars. So the insecure foundation just stays untouched.
And the craziest part is that this decade-old encryption still validated on brand new tenant accounts created this year. But they aren't the only ones. Look at this 4G industrial router from PUSR.
Oh, the router password issue.
Yeah. It had a hidden root account where the password was encoded simply by adding the hex value 0x61 to each character, modulo 256.
Which is an overly complicated way of describing a Caesar cipher.
Exactly. Adding a static hex value to a password is like trying to hide a secret message by just shifting every letter one spot down the alphabet. You know, A becomes B, B becomes C.
Yeah, a child could crack it with a pencil and paper.
Yet this is the security protecting remote root access to industrial routers over cellular networks.
It is a systemic failure to prioritize foundational security over shipping hardware quickly.
Even modern privacy companies are tripping over basic logic. ProtonPass, a highly secure password vault, had a catastrophic bypass in their emergency access feature.
That one was a real shock to the industry.
Yeah, the feature lets you nominate someone to access your vault if you lose your keys, and it enforces a wait time so you can reject the request if it's fraudulent. But if a user set that wait time to access none, an attacker who had compromised the user's email could add themselves as an emergency contact and instantly export the entire vault.
See, the system worked exactly as programmed, but the programming contained a massive logical flaw. It completely failed to account for the risk of immediate, unverified trust delegation.
And then there's OpenEMR, an electronic health record system used by 100,000 medical providers. ASL discovered 38 CVEs, including multiple CVSS 10.0 SQL injections.
For context for you listening, CVSS 10 is the highest severity score possible, total system compromise.
And the cause, unsanitized inputs in an order by clause.
An order by clause in a database is just the command that sorts the columns, like clicking sort by date or sort by name on a website.
Right, very standard stuff.
Very standard. But if the application doesn't sanitize the user's input, a hacker can replace the word date with a malicious command that tells the database to just dump all the patient records.
This is day one web security. This is the very first thing they teach you not to do in a computer science class.
It proves that while we are rushing to secure our cutting-edge AI models, our most sensitive infrastructure is still wildly vulnerable to attacks we theoretically solved 20 years ago. We are building shiny new interfaces on top of rotting digital foundations.
Which brings us to the ultimate wild card in all of this, the human element. Because while the technology is evolving, human ingenuity and sheer chaotic absurdity remains untouched.
Oh, absolutely. Humans are still the wild card.
The digital underground is getting fiercely competitive. This week, an unidentified group of hackers broke into servers that had already been compromised by a different threat group called Team PCP.
The economy of scale in the cybercriminal underground is truly fascinating.
They literally kitched the first hackers out of the system. They wiped Team PCP's malware tools, deployed their own self-spreading worm, and then stole Team PCP's credentials and resold them. There's zero honor among thieves.
Well, consider the business logic there. Why do the incredibly hard, noisy work of breaching a corporate firewall yourself when you can just hijack the infrastructure of a lesser hacker who already did the heavy lifting?
Work smarter, not harder, I guess. But speaking of doing the heavy lifting, human attackers are showing a deep understanding of system architecture that AI still struggles to replicate. Hunters detailed a technique called DMSA Ouroboros in Windows Server 2025. Tell me how this loop actually works, because it sounds like dark magic.
Yeah, a DMSA is a Delegated Managed Service account. It's a specific type of administrative account in Windows Active Directory. And the Ouroboros technique is basically a self-sustaining credential extraction loop.
Okay, so how does it start?
An attacker compromises a system, creates a DMSA, and manipulates the permissions so the new account has the right to read its own parent account's passwords. It then authorizes itself to continuously extract those password hashes.
So even if the IT team catches the breach and forces a network-wide password reset?
The loop continues. The DMSA simply extracts the new password. Even if you delete the original attacker account that set it up, the delegated account keeps running its extraction cycle.
That is wild.
And what makes this so insidious is that Microsoft closed the security report stating it doesn't meet the bar for a patch.
Wait, really?
Yeah, so not a bug, it's a feature of the Windows architecture being abused perfectly.
That is deeply unsettling. But my absolute favorite display of human creativity this week has to be data exfiltration using numeric-only outputs.
Oh, the base 36 trick.
Yeah. If an attacker is inside a highly secure system that blocks all text files and only allows benign telemetry data or numbers to exit the network, they are converting their stolen data into base 36 integers.
See, data loss prevention, or DLP systems, are designed to look for patterns like credit card numbers or text files containing passwords.
Right, so if you try to send out a text string of stolen data, the firewall catches it immediately. But how do you smuggle text out as a number?
By using base 36 mathematics. An attacker takes the alphanumeric text of the stolen data, runs it through a simple conversion script in Python, and outputs a massive, continuous integer. They can smuggle up to 2 kilobytes of data in a single number.
So the firewall scans the outgoing traffic, sees a giant, boring math equation, assumes it's just a system metric, and lets it right through.
It completely bypasses the filters. The attacker receives the giant number on their server, reverses the math, and gets the text back.
That is so clever.
It really is. This kind of deeply creative, context-aware lateral thinking is something AI agents still struggle to replicate in real-world environments. An AI can write a script, sure, but a human actor finds the bizarre architectural loopholes.
And sometimes, human actors just want to cause chaos. A security researcher remotely hijacked a Yarbo robot lawnmower, a heavy, blade-wielding piece of machinery that costs $5,000.
Yeah, this was a crazy story.
From thousands of miles away, the researcher took total control and drove it over a reporter's body. Safely, I should add, but still.
It perfectly encapsulates the absurdity of the Internet of Things. We are attaching dangerous, heavy robotics to our home Wi-Fi networks without demanding robust remote access security from the manufacturers.
So what does this all mean? We have to worry about our own gardening equipment turning on us.
Maybe just a little bit.
We have covered an unbelievable amount of ground today. We started with autonomous AI agents effortlessly solving complex hacking challenges that stumped humans just a year ago. We looked at how those same agents are being weaponized through plain English instructions hidden in code repositories.
And we examined the terrifying reality of Fortune 500 companies and medical providers failing at middle school level encryption and basic database input validation.
And we wrapped up with hackers stealing from other hackers, self-sustaining credential loops buried in Windows, firewall bypassing math equations, and remote-controlled lawnmowers going rogue. If you take anything away from this deep dive, it should be this. As the entire world rushes headlong into the era of vibe coding and agentic AI, the boring core tenets of security have never been more critical.
Absolutely. Validating your database inputs, ripping out legacy encryption, enforcing dependency cooldowns so you actually understand the tools you blindly trust.
The basics still matter.
They matter more than ever. The pace of the threat landscape is accelerating exponentially, but the foundational rules remain exactly the same. If your foundation is rotting, it really doesn't matter how advanced your AI firewall is.
Which leaves us with one final lingering question to mull over. If we are entering an era where autonomous AI agents become the primary software developers and competing AI agents become the primary attackers discovering the microscopic flaws in that software, what happens when human comprehension is entirely removed from the security loop?
It's a scary thought.
Are we building a digital ecosystem where we are no longer the administrators, but merely the bystanders, just watching machines fight machines at speeds we can't even perceive?
It's definitely enough to make you look sideways at your lawnmower.
It really is. It's a wild new world, but the more you understand the mechanisms behind the madness, the better equipped you are to navigate it. Keep asking questions, keep checking your dependencies, and stay insanely curious. We'll catch you on the next deep dive.
Spoken Tech, for your ears.